Right, time to introduce the next concept associated with stoichiometry for which we use our roadmap. And that's the idea of limiting reactant. Now, before we actually introduce the full concept of limiting reactant, let's go ahead and do another quick couple of examples that we'll use for that. So we'll take this equation here, 2Na plus H2SO4 goes to NaSO4 plus H2. Again, notice how sweet I am in that I have balanced the equation for you. How many grams of H2 will be made from the reaction of 2.3 grams of Na? So here's our Na, we got 2.3 grams of that. How many grams of H2 are we going to make from this equation? And because of the way we do this class, we're going to use the roadmap. Here's the full chapter 3 version of the roadmap, relating moles on each side, moles to each other, moles of A to moles of B, and then for each mole box we have it related to the number of particles to the grams, and then of course liters of solution there. So let's do our usual. What do we know? Where are we going? We know that we have 2.3 grams of Na, so that will be our starting point. We are asked about the number of grams of H2, so this will be our end point. So let's box that particular part of the roadmap that we're interested in and pull that out. So there it is, pulled out with the values thrown in. 2.3 grams of sodium our start, unknown number of grams of H2 at the end. Let's go ahead and do what we've done before. So the first step is to go from grams of the sodium to moles of the sodium. So let's quickly set that one up. I'm going to not dwell too much on these. After a while it does become very tedious for you all, I know. So anyway, grams of Na to moles of Na, the relationship we use. Grams is moles times molar mass. Molar mass of sodium is 23. We have 2.3 grams. Plug that in again using numbers so that we introduce concepts without befuddling you by worrying about the numbers themselves. 2.3 grams of sodium is 0.1 moles of sodium. So now this box here is 0.1 moles. Second step, we're going to go from the moles of sodium here crossing over to the moles of H2 over here. Done this several times of course by now. Relationships, the mole ratio is the ratio to coefficients. Moles of H2 we don't know. Moles of sodium is 0.1. Coefficient of H2 is 1, coefficient of Na is 2. So we plug all that in. Moles of H2 is going to be 0.1, bring that up here, times 1 over 2. So that equals 0.05 moles of H2. Put that in that little box. And then of course the third step to go from the moles of H2 to the grams of H2 really shouldn't be an issue for you all at this stage. Grams is moles times molar mass. We're dealing now with H2, so therefore the molar mass is 2 grams per mole. 0.05 times 2 is 0.1 grams of H2. So the answer to this question, if we have 2.3 grams of Na, then that is ultimately going to be calculated to produce 0.1 grams of H2. At the risk of redundancy, because we do need it for this concept, let's do another one. Same equation. Going to look very much the same. How many grams of H2 again, but now will be made from the reaction of 2.45 grams of H2SO4. Again, here's our roadmap. Let's plug in what we know. 2.45 grams of H2SO4, that defines this A side as the H2SO4 side. We are asked for grams of H2, that defines this side as the H2 side. Again, we're going to go grams, 2 moles, 2 moles, 2 grams. Let's box that out and pull it out. So again, 2.45 grams H2SO4, unknown number of grams of H2. Same process. So I'm going to kind of go through this quickly. Alright, remember the nice thing with PowerPoints is you can pause, go back and so forth. But we have 2.45 grams of H2SO4. First step going to moles, so therefore grams to moles. Blah 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 blah. Right, grams is moles times molar mass. The plug in 2.45 grams, molar mass of H2SO4, 98.1. We get 0.0250 moles of H2SO4. Next step, having put in the 0.025 moles, we're going to go from moles of H2SO4 to moles of H2 using the ratios. Plug everything in this case, kind of nice because both of the coefficients are 1. Coefficient of H2 is 1, coefficient of H2SO4 is 1. So the moles of H2 that we don't know is the moles of H2SO4, the 0.025 times 1 times 1, which is 0.025 moles of H2. And then of course last step is to go from the moles of H2 to the grams of H2. Nice little olive colour there, moles of H2 to grams of H2, grams is moles times molar mass, the usual relationship, and so we end up that 2.45 grams of H2SO4 is enough to give us 0.050 grams of H2. So we'll plug that in there. So why was I so repetitive? We did. Well, now let me give you another question. We've got that 2.3 grams of Na makes 0.1 gram of H2, 2.45 grams of H2SO4 makes 0.05 grams of H2. How about how many grams of H2 will be made if we take 2.3 grams of Na and emphasize the and, if we were in class I'd shout it at you, but I don't want to shout through your computer speakers, but 2.3 grams of Na and 2.45 grams of H2SO4. I'm going to do this as a multiple choice. Is the answer 0.15 grams, 0.10 grams, 0.05 grams, or the ever popular none of the above? Now, while you're thinking about this, I'm going to start talking about my wife. I have an amazing wife. Right? She gets up every morning and she takes 2 bits of bread and a bit of cheese and makes me a sandwich that I'm going to take in for lunch. So let's say that one morning she gets up and she finds that she has 4 pieces of bread. How many sandwiches can she make out of that? And of course the answer is 2, because you need 2 bits of bread for every sandwich. So if you've got 4 bits of bread, you can make 2 sandwiches. Now imagine another morning. She gets up and she finds that she has 3 pieces of cheese. How many sandwiches can I get that day? And of course you say, well, the answer is 3, because I need 1 piece of cheese for every sandwich. Now the trouble is that there's a little bit of information that one is assuming. When you say you got 4 bits of bread, you can make 2 sandwiches for that. Obviously you must have some cheese. You're assuming that you have the cheese, but you're not given that in the question. The question is, if I have 4 bits of bread, how many sandwiches can I make? Assumption being, of course, there is enough cheese. In the same way, when she has 3 bits of cheese, how many sandwiches can she make? Well, 3. Well, that's assuming, of course, that she has enough bread. Well, now, how about if one morning she gets up and there are 4 bits of bread and 3 bits of cheese? How many sandwiches is she going to make that day? And of course, you know, well, if you got 4 bits of bread, that's enough for 2 sandwiches. 3 bits of cheese enough for 3 sandwiches, but you've only got enough bread for 2 sandwiches. So of course you know that I'm going to get 2 sandwiches that day, because what you have done is you have said, well, you're going to make the smaller possible amount, the smaller amount of the product. The way that we phrase that is we can also say that we've got bread, we've got cheese, but the amount of bread limits the number of sandwiches, right? There's only enough bread for 2, there's enough cheese for 3, but there's only enough bread for 2. And so we have an excess of cheese. Cheese is in excess. All right, well, now you can take a break and go off and make yourself a cheese sandwich, because I know you're hungry. And then we're going to get back to the actual chemistry. Let's refresh ourselves. Here's our reaction. Okay, we calculated that 2.3 grams of sodium would be enough to make 0.1 gram of H2. Well, the assumption there is, I've told you about the sodium, you're not going to make any H2 unless you've got H2SO4. So the assumption is you have enough H2SO4 to use up all of the sodium. And then we said, how about if I have 2.45 grams of H2SO4? How much H2 can I make from that? And you calculated 0.05 grams of H2. Well, of course, you're not going to make any H2 if you don't have any sodium. But in this second question, we assumed we had enough sodium. So then I put them together in just the same way we did in the sandwich making. how many grams of H2 will be made from the reaction of 2.3 grams of sodium? Well, that's enough to make 0.1 gram of H2. And 2.45 grams of H2SO4, well, that's only enough to make 0.05 grams of H2. So would you care to reconsider your answer? A lot of you probably, when you saw this and, just said, well, 0.1 and 0.05 makes 0.15. But no, we only have enough H2SO4 to make 0.05 grams of H2. We can only make the smaller amount of the product, which is the 0.05 grams of H2. So the answer to this question, we have enough when we've got 2.3 grams of Na and 2.45 grams of H2SO4. We have enough Na for 0.1 grams of H2. We only have enough H2SO4 for 0.05 grams of H2. Again, H2SO4 is the limiting reactant. Na is in excess. Finally, just to switch gears a little bit and throw it in, it's not exactly the hardest concept in the world. When we have been doing all these calculations, we have been calculating the so-called theoretical yield of a reaction. That last example, the theoretical yield of our reaction was 0.05 grams of H2. But of course, you actually have to do a reaction. And when you go in and do a reaction, you probably won't get that theoretical yield. You won't get as much as you're supposed to. When you do the experiment, you get the actual yield. So the way that you often talk about when you're a chemist different reactions is you report the so-called percent yield. The percent yield is simply what you get, the actual yield, over what you could have got, the theoretical yield, times 100.